Assalamualaikum warahmatullahi wabarakatuh. Hello guys, so today I want to presentate about about that embedded system. Tutorial embedded system. Okay, so first and first, I would like to explain to you what is embedded system. So, embedded system is a field that studies microprocessors by combining various of hardware and software programmatically in a computer system or computer-based system that can be amplified to meet computing needs in general. Of course, the goal in enable it in human life. Embedded implementation. This system is very broad, not only limited to microcomputer system, but also computer computer-based embedded systems, control system to the Internet of Things. Digital clocks, smartphones, MP3D players, traffic lights are example of embedded system. Implementation classified as microcomputer embedded system, while the implication of the control system can be formed in large or small scale ma- manufacturing robots or also device with manual slash automatic system. There are many embedded system implications that we often see in or use in our daily life. Until the industrial revolution 4.0 embedded system field development which became famous, namely the Internet of Things, where device systems can communicate using the Internet. Next, embedded system architecture. Basically, the embedded system is a composed of mechanical software and hardware, where mechanical is a physical model of embedded system. Device and software can be in the form of a program that is embedded in the hardware controller or in the form of a user interface program that is also integrated with the hardware, while the hardware is the form of input, output, complex and processor control brain in a physical form to be used as a component that works in the embedded system. Embedded system architecture. In the forms of system, of course, it contains three system requirements for work, namely input, process, and output. Inputs to embedded system can be in the form of sensor hardware or in the form of injection data software to be further processed by the control brain, which is often an IC chip or microcontrol hardware so that the result of this process will produce output either in the form of a bin or the architecture hardware or in the form of output device display hardware. Sensors or an actuator. Sensors are devices that detect and measure any change in the physical environment. It converts a physical quantity into an electrical signal. It takes any output from the real world and environment and feeds it into a system in the form of electrical energy signal. It is connected at the input of a system and supplies all the data required for processing. There are different types of sensor available, namely temperature, ultrasonic, vibration, and position sensor, and others. Microsensors are devices that convert electrical signal into mechanical work. It converts electrical energy into mechanical energy. Architecture are used to generate motivation or environment changes. For example, a fan is used to reduce the temperature. Servo motor are used to change positions and act. Architects are connected to the connected at the output of the system. It takes an electrical signal as input and generates a mechanical movement as its output. These are the sensors that we use in embedded system. Sensor proximity, sensor heat sensor, ultrasonic sensor, voice sensor, like that and like that. Embedded system are three form control system, example of smart parking and smart trash. Two is robotics, example of robot to be does bombs, exploring, shipwrecks. Third is Internet of Things, example of smart cities, smart homes, and smart gardens. ESP32 is a low cost system on chip SOT microcontroller from the expressive system, which is also the developer of the ESP8266 SoC, famous for Node MCU. The ESP32 is the successor of the ESP8266 SoC using the Extensa LX632 bit 10 silica microprocessor with an integrated Wi-Fi and Bluetooth. The hardware designed for those for ESP32 is very easy because it requires only a few external components. The ESP32 board has 30 pins, 50 pins on each side. There are also some board with 36 and some with fewer pins. So double check the pins before making any connection or even turn on the board. The advantage of ESP30 is that it has many pins that can function as analog or digital according to the configuration. ESP32 is like this. KBIDE. Maker Asia is a Thailand-based technology company which development both hardware and software. The company develops various microcontroller boards such as ESP32, Raspberry Pi, and other microcontrollers. Apart from the hardware, they also develop some software, one of which is KBID. KBID is an ID integrated development environment that can be used to program microcontroller boards such as KitRun. Arduino UO, ESP32, and others. Hobby ID is open source. It is available on GitHub because it's open source. We can extend it so that user can development. For example, by adding new boards, plugins, libraries, and more. Blink. Blink is one of the most popular Internet of Things platform with new and pure UI, lots of widget feature, and easy configuration. Blink is suitable for beginners who want to get involved in the world of Internet of Things. Blink provides server service as well as an interface for its users so that we can monitor and control our device via the internet in the Blink application. For a more advanced experience, a Blink is also available on the local server, where the development can independently configure servers, more complex widget options, and more secure privacy. This is because Blink local server runs on our server, the environment we created, so we can set up server security independent. Blink looks like this. Okay, that's the explanation. Thank you for that.